Welcome back. We are at section 5.5, inequalities and triangles. We first start off with review from a problem that we had at the beginning of Unit 4. And hopefully we can recall that angles 3 and angle 2 are called remote interior angles. And that we recall that angle 1 would be considered an exterior angle because it's on the outside of our triangle, and then remote interior on the inside. If we knew that angle 1 was, say, 140 degrees, that means this angle inside would be 40 degrees by linear pair. It also means that the measure of angle 3 plus the measure of angle 2 would have to equal the measure of angle 1. And that should make sense because we know there's 180 degrees in all triangles. If we used up 40 of it on the right side, then we know that these two angles would have to add up to 140, which is what we got for the exterior. So we're going to say that measure of angle 3 plus measure of angle 2 is equal to measure of angle 1. We can also say that measure of angle 1 is greater than measure of angle 2, and measure of angle 1 is greater than measure of angle 3. We're going to skip the next drawing. We're going to jump down into our theorems. And so for these next three theorems, I like to think of the term as common sense, meaning let's take a look at what these are saying, because really we just use common sense when dealing with these theorems, and we can tell which sides and which angles are shortest, longest, etc. So we're saying that if xz is greater than xy, so let's say on this drawing that we knew this was 6, and this was 4, and this was 5. Well, if this was the case, then angle y would have to be the biggest angle, okay, because it's opposite the longest side. So angle y would be the biggest angle. Then angle x would have to be our second biggest angle, so angle y and then angle x, because it's across from our second biggest side. And then angle z would have to be our smallest angle because it's opposite our smallest side. Okay, and so that's what I mean by using common sense. It also works that if we knew that, let's say that BC was 8, AC was 6, and AC was 5, then we can look at the opposite angle from BC would be angle A. So angle A would be our biggest angle. And then angle C would be our second biggest angle. And then angle B would be our shortest angle. Alright, and then this is a very important theorem. We'll use this a lot. The sum of the lengths of any two sides of a triangle is always greater than the third side. So if we had a triangle like 1, 2, and 20, will this triangle exist? Well, again, let's use common sense. If we have side 1 and we have side 2, is there a way that this side length could add up and be 20? Well, no. There's no way that that's going to be humanly possible. We can't have a side length of 1 of 2 and then have 20. It's just not going to work. Okay, so the reason why this won't work is that 1 plus 2 has to be greater than that third side, and it's clearly not greater than 20. This would be false. Therefore, this triangle does not exist. So what we want to fill in down below is that Ln plus Mn is greater than Ln, greater than Lm, and greater than Mn. So let's do a few more of these. What about 4, 5, and 8? Is it possible to draw a 4, 5, 8 triangle? Well, yes it is, because 4 plus 5 is greater than 8. This is true. Therefore, it's possible. I can put a yes here. Next, let's do 2, 5, and 7. Well, this is going to be no, because 2 plus 5 is not greater than 7. This would be false. So I say no, this triangle does not exist. Let's do one more. What about 5, 5, and 10? Well, 5 plus 5 has to be greater than 10. That's false. So this would be a no. So moving through our notes, again, we're going to look at each of these shapes and decide which angles on the left and which sides on the right from shortest to longest. And again, we'd like to use common sense here. So we look at the smallest side, which is YG. That means the angle opposite will be our smallest angle. So angle R would be smallest. Then angle Y, because it's opposite, our middle size shape. And then angle G would have to be our biggest angle because it's opposite our largest side. Same thing here with A plus 1, or excuse me, A minus 1 is our smallest size, so it has the smallest angle. Middle size would be angle X, and then our biggest angle would be angle Z. All right, we have 46 and 42, that's 88. 180 minus 88 would give us a 92-degree angle. Clearly not drawn to scale, right? There's no way this is a 92-degree angle, but we can still solve the problem. Shortest would be AB. Middle size would be BC. And longest side would be AC. And so again, we focus on each angle and then the opposite side. 63 plus 27 would give us 90. So this is going to be a 90-degree angle. Again, clearly not drawn to scale. So XY would be our shortest side, ZY second shortest, and then XZ would be our longest side. Alright, this next drawing is not drawn to scale. It's going to confuse some of us just visually, and that's okay. What really should happen here is if we were to draw this shape to scale with everything that's shown here, then it would actually look like a kite. Okay, and this side would do something like that. So again, if this scale was, or if this shape was drawn to scale, it would look like this, but it's not. Okay, so this is what we have to go off of. 52 plus 48 is 100, so we'll put an 80-degree angle here. And 65 plus 55 would be 120, so we'll put a 60-degree angle here. All right, well, you have two triangles, and this is what makes this problem visually confusing. You have this triangle on the left, and then you have this triangle on the right. Now, with the triangle on the left, it's going to be clear to us that side SU would have to be the longest side for the triangle on the left. Okay, but when we look at the triangle on the right, we look and we see that the biggest angle is 65 degrees, so the side opposite would be ST. And that would be our longest for the triangle on the right. So the question is not asking us for the longest on each side. We're being asked for the longest one total. Now, if we ignore what we just did and we just look at how this shape appears, it would seem like SU would be our longest shape. It just looks like this shape is longer than ST. But remember, this shape should actually look like this. And so here's ST, and clearly ST is much longer than SU. So again, we're back to that same question, which one is it? Well, since this triangle has SU as its longest, and this triangle on the right has SU as its shortest, right? Because here's the shortest angle, then it can't be SU for the longest, because it's the shortest for the triangle on the right. So it's going to be ST. And again, that's very confusing to see, but that's how we do it. Same thing on our next shape. We have 122, so 58 degrees down below. And then 102, so that would give us 78 degrees up above. Well, again, we have two shapes. We have two triangles. We have the triangle on the left, and we have the other triangle on the right. And just like we did on the last triangle, let's look at the triangle in pink. The longest side in this triangle would clearly be BD. Why? Because it's opposite our biggest angle. And then for the triangle in green, we see that our largest angle is 78, and the opposite would be DC. And we run into the same problem that we ran into that last shape. I understand that BD looks like it's the longest segment, but again, this is not drawn to scale. Okay, and if we go by the rules of each triangle, that means DC has to be the longest side. Next, given any three segments, is it always possible to create a triangle? No, this goes back to our 1, 2, and 20. This is not possible. It will not exist. When given three segments, a triangle can be formed if we want to say one side is less than the sum of the other two sides. So we have, is it possible for a triangle to have sides with the following lengths? Well, we have 4 plus 5 is greater than 6. This is going to be true. And so we can say, yes, this is true. 2 plus 2 is not greater than 4. This would be false. No. 8 plus 5 is greater than 12. This is true. So we can put yes. We can do these as well by subtracting, but I'll show you that at the end. Okay, so for now, we're just going to add our two sides up and then see if it's greater than our third side. Next, when given two sides of a triangle, the third side must be greater than the difference and less than the sum. Alright, so last problem. We're told that we have a length of 3, of 7, and then a question mark. And to find this question mark, we need a range of values, because we want to find, or we're being asked, that the length of the third side must be, and then dot, 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 which means they want a range. Okay, so it's not just going to be one answer. The way that I do this is I take 3 plus 7 and see that it's going to be 10. I know that x, the unknown side, has to be less than 10. So I'm going to say, okay, x is less than 10. It has to be less than 10. What we said with this rule right here and this rule right here is that we can also subtract these two. And I get 7 minus 3 is equal to 4. So I know that x has to be greater than 4 and x is less than 10. I can also put x in the middle and say that 4 is less than x, which is less than 10. So you can show this range as x is greater than 4 and x is less than 10. Or you can say 4 is less than x, less than 10. This is known as a compound inequality. Okay, but it's your choice here. Okay, you can use the word and, or you can put x in the middle. So what we're really saying is that x is between 4 and 10. Okay, so any value between 4 and 10 would work. So we could have a 3, 7, and a 4.00001 triangle. This would exist. Okay, or we could have a 3, 7, and a 9.999 size triangle. This would work too. Okay, and you get the idea. 12 and 19 add up to 31, x has to be less than 31. Okay, and I want to say that 19 minus 12 is 7, so x has to be less than 7. Sorry, x has to be greater than 7. Now, one thing that I didn't do here right is let's put x is greater than 7 first, and x is less than 31, or we can put x is between 7 and 31. Thanks for watching. See you next time.